FWGDMEHLSN. No, I'm not under the influence and unable to recite the alphabet. But what are these random letters of the alphabet, and what do they have to do with this episode? Well, you're just gonna have to stick around to find out, so let's get hacking. What's up, everybody? Welcome to part 4 in our mini-series on Spreadsheets. I'm James with Microvellum, and this is Wood Hacks. Going back to the intro, what do these random letters of the alphabet mean when it comes to Microvellum and Spreadsheets? Well, they're references to the different workbooks within Microvellum. And so, in this episode, we're going to discuss the different workbooks and the ways these workbooks communicate with each other. So let's get started. All right, so here are the different workbooks available within Microvellum. Starting from the top, we have the Factory Workbook. The Factory Workbook contains various prompts and settings that control different aspects of the software that are typically accessed in other interfaces outside of what users are typically used to. Settings in the Factory Workbook also contain lists that are considered library-wide that can appear in all libraries, projects, products, and subassemblies. Editing the settings in this workbook should be done with caution and by an experienced user. Below the Factory Workbook, we have a group of workbooks that make up the spec groups: Project Wizard, Global Variables, Door Wizard, Cut Parts, Edge Band, and Hardware. These workbooks are used to set up the project and feed into and provide default values for the products and subassemblies within a project. The Project Wizard contains variables and settings that are commonly changed per project or even per different materials setup. The Global Variables contain settings that aren't changed as frequently, but also control certain variables and settings for products and subassemblies. The Door Wizard contains variables and settings that are commonly changed when projects have different door setups. After that, there are the 3 workbooks that make up our material files: Cut Parts, Edge Band, and Hardware. Each of these workbooks contain a list of materials, material pointers or assignments, and other settings. For example, the Hardware Workbook will contain machine tokens or machine instructions for the hardware items. The workbooks that make up the spec groups are then used to help populate the settings and values within the 3 different workbooks that make up a product. And those are the Local Product, Subassembly, and Nested Subassembly workbooks. Every product and subassembly has variables that can be changed through the Product Prompts interface. Many of those have default values that are based on the settings in the Project Wizard and Global Variables. You'll notice that each of the different workbooks has a designation that precedes it: F exclamation point, W exclamation point, and so on. I'll explain the significance of those in a little bit. However, I'm pretty sure everyone has accessed the different interfaces used to set up and control the different settings and variables available for setting up your libraries and projects, so I'm not going to go into any of those. But what I would like to talk about is the relationship between the different workbooks and how they communicate with each other. Looking at this hierarchy list, we can see that the Factory Workbook feeds into everything below it. The spec group files can communicate between each other and even feed and pull information from the Local, Subassembly, and Nested Subassembly workbooks. Notice, local products cannot communicate with other local products, but local products are able to communicate down to subassemblies and nested subassemblies contained within the product. Subassemblies can be viewed as secondary products contained within a product. Doors and drawer boxes are 2 easy examples of subassemblies. Again, if you notice, just like the local products, subassemblies cannot communicate with other subassemblies. However, they can feed into nested subassemblies, which are subassemblies contained within subassemblies. And there go all those inception thoughts again. But it's okay though, nested subassemblies can only go one level deep. This way you don't get stuck in an endless time loop or a rabbit hole. One last thing to mention with subassemblies and nested subassemblies is that they also cannot communicate up to the parent level, meaning a parent, local, or subassembly cannot pull values from the subassemblies below it. It can only feed them values. And I swear if I say subassembly one more time, I'm just gonna smack myself. All right, hopefully that's a good enough explanation of the different workbooks and how they communicate. Now, when it comes time to reading and writing formulas that are referencing the different workbooks, those prompts or defined names must be preceded by the workbook designation, the W exclamation point, G exclamation point. So, for example, if a subassembly is looking to a global variable, let's say the door to cabinet gap value, the formula in the subassembly would read equals G exclamation point door to cabinet gap. So when you see these designations within a formula, you can determine which workbook the data is coming from and track it back to the specific prompt, which will help you make changes in the correct location instead of corrupting a formula by stomping it out with a hard-coded value. All right, well, I hope this episode gives you a little better understanding of the different workbooks and how they communicate with each other, and will help you as you start reading and writing formulas. And hopefully, no one gets pulled over and accidentally recites these letters instead of the alphabet, because you'll be going to jail. However, that would make for one heck of a sobriety test. Follow my finger with your eyes. All right, can you name all the letters of the workbooks within Microvellum? F, W, G, D, M, E, H, A, B, C. All right, go ahead and step over here. You're coming with me. All right, well, keep an eye out for the next episode where we'll be working in the local workbook. You're gonna wanna make sure that you watch that one. And remember, drunk friends don't let friends drive. No, friends don't let friends drive drunk. And as always, stay sharp, stay focused, and stay awesome. And I'll see you next time. And again, nested subassemblies cannot communicate with other nested subassemblies. Oh, I can't say subassemblies. One last thing to mention with subassemblies and nested subassemblies. Oh, I can't talk. Oh, I will get through this. I will. Meaning, a parent, local, or subassembly cannot pull values from the subassemblies below it. It can only... This has been interesting. This was supposed to be quick, and it's not quick. This is ticking me off. Meaning a parent or local cannot pull values from the subassemblies below it. Subassemblies. Oh, I'm so tired of saying the word subassemblies. So, for example, if a subassembly... I'm not saying subassembly anymore in this video because that word is... It should just be banned. Should be banned from Microvellum and anywhere else that it may exist. I hate that word.